In this example, we're going to take what we learned in the previous video to see how to use Python to connect to a real-time JSON data feed and process the information. JSON stands for the JavaScript Object Notation, and you'll run into this a lot when you're working with data from various different sources on the internet. The data feed that we're going to be using is the U.S. Geological Survey's Earthquakes data feed, and I have their homepage open here. You can see here that the earthquake data feed is provided by the USGS, and they provide the feed in a variety of formats. So they have Atom, and they've got Google Earth KML, they provide JSON, and if you click on this link right here, the GeoJSON summary feed, then you'll get this page, and this describes the format of the JavaScript object that comes back from the data feed. So if we scroll down a little bit, you can see that there's information such as longitude, latitudes, there's generated times, there's some URLs, and then there's this big long features array that describes each earthquake. So here's the magnitude, the place, the time, there's a longitude, latitude in here somewhere. So we're going to be using this feed to get information about current earthquakes all around the world. Now, it's beyond the focus of this course to teach the concepts of JSON. So if you need to learn the basics of JSON, then you should consider watching the JSON Essential Training course first. All right, let's go over to our editor. In the editor, we're going to open up JSON data_start. To be able to use Python to process JSON, I first have to import the correct module, which is the JSON module, and that is part of the Python standard library. So I'm going to go ahead and import JSON. So I've already defined the main function. So if we scroll down a little bit, you'll see that here is the main function, and I've got a variable here called URL data, which is pointing to a URL that the USGS uses to deliver JSON data for all the earthquakes that have happened within the last day that were larger than a magnitude of 2.5. And just like in the previous example, I also have a web URL variable, and I'm calling the URL open function on the URL to get the data. So first, I'm going to print out the result code to make sure that we're getting a result code of 200. If result code comes back as 200, we're going to read the data from the URL and process it. This will retrieve the JSON data from the website, and we're going to write a function called print results, which if we scroll back up, you'll see is right here, and print results will print out our customized results from the JSON data feed. So let's go ahead and write the code to check to make sure everything's okay. So I'll write if web URL.getCode is equal to 200. Then I'll get the data, and I'll define a variable named data, and I'll call web URL.read. And then we'll print out our customized results using the data. Otherwise, we're going to print out an error, and the error will say received an error from the server, cannot print results, and we'll print out the web URL.getCode. Okay, so now let's fill out the print results function. So print results is going to take the JSON data object, all right? And you can see I've already written a line of code that you see here that calls the load_s function on the JSON module, and that assigns the result to a variable named the JSON. So the load_s function takes a string of JSON and parses it into a native Python object, in this case a dictionary. So once we've done that, we can access that object like we would any other Python object. So for example, according to the GeoJSON spec, there's a property named title in the metadata section. So let's go ahead and print that out. So I'll check to see if there is a title key in the JSON, and we're going to check the metadata section. And if there is, I'm going to print the JSON, and in the metadata section, I'm going to print title. So let's save, and let's quickly go back to the browser. And back here in the browser, you can see in the metadata section, I'm getting this title right here. So this is the key that's going to be in the dictionary, and then that itself is a dictionary. So I'm going to get the title key from the metadata dictionary and print it out. Also within the metadata section, it looks like there's a count property, which tells us how many earthquakes there are in the dataset. So let's go ahead and print that out as well. So I'll get the JSON, and once again, I'll look inside metadata, and I'm looking for count, and I'll print out count events recorded. All right, so let's go ahead and run what we have so far. So I'll save, and I'll right-click and choose Run Python in my terminal. And sure enough, we can see the result code is 200, so that's working. This is the title right here, USGS magnitude 2.5 plus earthquakes in the past day, and we can see that there are 33 events recorded. All right, so we're making some good progress. Now let's print out some of the details from the earthquake data structure. So let's close the terminal, and let's go back to the spec. And if we look in here, all right, we can see that there's a property named features. All right, so this is an array where each entry has an object named properties that represents the details for each individual earthquake. So we're going to write some code that prints out the place where each one of the earthquakes occur. And you can see that there's a place string right here. So let's go back to our code. So what I'm going to do is write a loop. I'm going to write for I in the JSON, and we're going to look in the features array, because remember features is a list. We're going to loop over all of the feature entries, and I'm going to print in the properties object, I want to print out the place. And then after that loop completes, I'm just going to print out a little spacer so that we can keep all of our data separate. So now let's run that. So I save, and let's go back, run this in the terminal. And let's see. All right, so we've got a list here. Okay, so here's our list of events, right? So we've got 33 events recorded, and we've got off the coast of Bison, Chile, we've got 50 kilometers southwest of New Mexico, we've got one in India, there's one in Hawaii. So you can see that we're getting all of the recorded earthquake events that were larger than 2.5 magnitude, and there's 33 of them. All right, so making even more progress, let's print out a list of all quakes that have a magnitude of 4 or greater, and we're going to examine the mag property of each quake to do this. All right, so once again, I'll have a loop for I in the JSON, and we're going to be looking over features. So I'm going to check to see if that element, and we're going to look at the properties, I'm going to look at the magnitude key. So if that is greater than or equal to 4.0, then I'm going to print out properties and the place. And then once again, I'll have my separator. So once again, let's save and let's run. All right, so let's go back up and scroll. Let's find the first separator. Okay, here's the first separator. So these are going to be all the places where the magnitude was greater than 4.0. And you can see that there's a subset of all the earthquakes we've seen so far. So let's do one more example. Right. For the last example, let's print a list of quakes where at least one person reported feeling something. So let's look back in the spec. And back here in the spec, we'll see, if we look down in the spec here somewhere, where is it? There it is. There's a felt property right here. And this is the number of people who have felt the event and called it in and reported it. So let's go update our code. So let's go ahead and print out events that were felt. Okay. And then once again, I'll have my for loop. So I'll just copy and paste this. So we'll get the number of felt reports, assign that to a variable, and that's going to be in each item, there's the properties, and there's going to be the felt property. And I'll say if felt reports is not equal to none, so the property exists. I'll then say if felt reports is greater than 0, we're going to print the properties in place. So once again, I'll just copy this right here and paste it in. All right. And we'll also print the felt reports times. Okay? So let's go ahead and save, and let's run this one last time. And we can see that our last list, these are all the events that were felt. So we've got one in Colombia that was felt twice. Here's one in Japan that was felt 18 times. Now keep in mind that the data that you're going to be seeing is different than the data that I'm seeing here. And obviously that's because, I'm looking at this data as of the date of this recording. And when you look at this data, this is going to be live, real data. So your data is going to look different than mine. But I think you can see here, though, that using Python to retrieve JSON data from the internet and manipulate it and process it is really pretty easy. And to learn more about the JSON handling features of Python, you should check out the documentation for the JSON library here on the Python website. And while you're at it, I was just taking some time to experiment further with this example and maybe try some of the other properties that we haven't touched on.